Thank you so much. It is truly an honor to keynote this morning and talk about what I know is going to be a very relevant set of topics, and one which I would like to think brings to bear so much of the technical information we are sharing here at Gloc. I'll start by making a very simple statement. The wolf is in the house. The wolf is no longer at the door. The wolf is not out in the field. The wolf, which is climate change, is in our house. We are all feeling it right now. This is no longer a theoretical consideration for our children and our grandchildren. Let me ask the audience a couple of questions. How many of you own condominiums in Maui? Yeah, I didn't think so. How many of you live in the interior in Alaska? I didn't think so. How many of you buy insurance? I thought so. Now let's make it easier. Show of hands. How many of you like to eat? If your hand is not up, please ask your neighbor to help you out. Every one of those questions is tied to issues associated with climate change. We're feeling the impacts. We're feeling the effects in terms of the economy. We're feeling the effects in terms of health. We're feeling the effects in terms of food security, water security, energy security. So everything we're talking about here at this conference has direct and immediate relevance, not just to the people in this room, to any person on the street, anywhere in the world. It's my goal here in the next few minutes to share with you some perspectives about how the work that is done, especially in the framework of remote sensing, directly impacts our ability to make decisions. Decisions at the level of the individual, decisions at the level of government decision makers and policy makers, decisions at the level of industry, tied to any number of threats which are depicted in this particular slide. We tend to get a little bit biblical when we talk about climate change. We talk about floods, fires, coastal inundation, heat health. But these are the things that are affecting all of the securities that I talked about a minute ago. So what are we doing about it? What are the things that we, as technologists, scientists, engineers, policymakers, need to do to help ourselves get to what in the US we are calling a climate-ready nation? And I would argue that that's all part of a climate-ready society and a climate-ready globe. Our ability to have accurate, reliable data, translate that into information, translate that into knowledge, and translate that into intelligence is what is at the heart of what we are trying to do here. So think of this as a flowchart, if you will. I don't expect you to be able to read every detail of this slide. It violates every principle of PowerPoint slideology, but I will tell you it brings an important point to mind. And that is that in order to be a climate-ready nation, we need this full spectrum of expertise and capabilities, going from the fundamental understanding of how to make observations, what to make observations of, when and where to make those observations, then taking those observations, those data, translating them through research and development into product lines that meet the needs of communities. And oh, by the way, an important aspect of this is co-development. So that on the far left of this curve, you're actually talking with the individuals, the institutions that need to solve problems. Then building those capabilities, enhancing capacity for communities, for geographies, for different sectors like the emergency management sector, and transmitting that intelligence, that environmental intelligence, into the hands of people who can make decisions. Evacuate, don't evacuate. Invest, don't invest. Store water, don't store water. Make those decisions, make those applications, and then evaluate. How well did we do? Did we solve the problem? Did we improve the ability to pre-position and mobilize in the threat of some emergency? And then start the whole cycle again. This is at the heart of what an agency like the U.S. National Oceanic and Atmospheric Administration is all about. I can point to this slide and I can say, this particular capacity for making observations, this particular capacity for translating and transmitting and conveying and disseminating information resides in this part of the organization. But wait, there's more, because you need to frame this around the value chain that is specific for fire, for drought, for flood, for heat, for coastal inundation, for marine resources. At NOAA, we also operate the National Marine Fisheries Service in the United States. So we need to be able to take this information and be able to tell the fishing community in Alaska that 20 years from now, you're going to be catching more Pacific cod than salmon. You better start thinking about how to structure your industry around a fundamental ecosystem change. We also have to consider the scales. So it's one thing to deal in IPCC, global stocktaking direction, and talk about national level observations to support reaching nationally determined contributions to carbon dioxide reduction. It's another to turn to the local community in a small town in Florida and say, we can provide you a tailored sea level rise product that you can use to make decisions about building a seawall in the next 10 or 15 years. So this whole value chain really captures what a climate-ready nation is all about. At NOAA, we have a couple of other priorities we build into this. Obviously, establishing that role as the authoritative source for operational climate products and services is critical, in much the same way that having authoritative sources for things like navigational charts is critical. You don't want to go shopping for who can sell you the cheapest navigational chart. You want the most authoritative navigational chart. Similarly, climate products and services, you want to know that what you're getting is authoritative, reliable, accessible. We also want to do this in a sense of balance. And this is where many of the issues that we are doing in terms of being good stewards of the environment at NOAA, but also part of the United States Department of Commerce, mean that we should be looking at how we can build out economic opportunities. And I share with you, by one way of example, that in the 2 years I've been on this job, I've met with about 150 startup companies working in the climate enterprise, what I call the climate industrial complex. How can we do our job in observations in that full spectrum I just shared with you, and at the same time make sure we're supporting entrepreneurs, investors, venture capitalists to build out new capabilities? And this third pillar I can't overemphasize, and that is the one of equity. When we put out products like urban heat predictions, are we really being equitable? In a city like Chicago, we can see as much as 5 to 10 degrees centigrade difference in a developed community versus an underserved community in the heat that they will face. That has enormous consequences in terms of health impacts. So our role to exhibit equity in how we build and provide services means making sure that all communities, unserved, underserved, have a voice at the table, not just at the end of the process, but up front, telling us what is needed, when is it needed, how can it be delivered. The assumption of dissemination, in many communities, they have no access to standard internet connectivity. How do we make sure those communities can get the products? It's no good in that value chain if you get all the way to the stage of the dissemination and you cannot get that environmental intelligence into the hand of an underserved community. So let's get into the actual nuts and bolts. At NOAA, we have this enormous portfolio of capital assets that we use to make the measurements on land, at sea, in situ, remotely. And what you're seeing here is just one sense. We like to say at NOAA that we make observations from the surface of the sun to the bottom of the ocean. And in doing that, it means measuring not just the traditional physical parameters, if you will, sea surface temperature, atmospheric chemistry, but also having responsibilities for tsunami detection out at sea. Also having responsibilities for measuring the health and distribution of corals, not just around US waters, but around the world. We provide the navigational charts in the United States exclusive economic zone. And of course, I'll say a lot more about the middle slide and the bottom right slide in terms of our remote sensing capability. We have a Navy, we have an Air Force, we operate 17 satellites, 16 ships, 9 aircraft, and we do all of that to supply the environmental data and information that I've just alluded to. I'll talk a little bit more about our GOES-R series, about our LEO series, as well as some of our space weather observations. And in fact, we're very proud of the fact that just last year we enjoyed 2 launches and 2 classes of our satellites, the geostationary satellites, GOES-T launch, which became GOES-18, which is now our West Coast geostationary satellite. It observes many of the Pacific hurricanes. It observes the atmospheric rivers that we've heard so much about hitting California this year. And then, of course, in our low Earth orbit, we have the JPSS-2 launch, which was in November, shown here as well. That's now the NOAA 21 satellite. I'll say a little bit more about the specifics on that. The GOES-18, as it's now called, GOES-T, shown here at launch, went operational about a year ago. NOAA 21 will be operational later this year. These satellites are providing us extraordinary capabilities, sounding and imaging. On the left, you see the GOES-18 image showing some of the atmospheric activity. We have the advanced baseline imager. We have the geostationary lightning mapper. We also have solar observations on the GOES satellite. And on the right, you see the JPSS-2, again, now called NOAA 21. And this includes a whole range of cross-track infrared sounder. It includes the ozone mapper. It includes the advanced technology microwave sounder, as well as the visible and infrared imaging radiometer suite. So you can see that we're starting to get extraordinary quality, extraordinary resolution, and all of this is fine, but unless we can start demonstrating what this is doing for us, it's nothing more than pretty pictures. And so I can tell you that using these kinds of capabilities and quantitative approaches to Earth observation, we've been able to dramatically improve things like our hurricane track and intensity forecast. Track forecast, we've improved probably about 20 or 25% in the last 20 years, largely due to remote sensing capabilities, but also due to some of our airborne aircraft capabilities. Intensity, we've also made improvements, not quite as much, but that's where some of the new capabilities for observing things like total ocean heat content are really going to help us make these dramatic improvements. We're very excited about the current capabilities for doing a whole range of things. I'll show you some specific products and get back to this value add concept in just a moment. But I wanted you to get a general sense of the current set of capabilities. What's in front of us in terms of capabilities in the future. Advancing some of these capabilities on low Earth orbit, our near Earth orbit network, or NEON, is going to look at things like hyperspectral infrared soundings, radio occultation soundings, working more closely with the private sector in terms of incorporating capability. But I'm particularly excited about some of the things that you see here with respect to both our GEO and LEO capabilities, enhancements in visible infrared, nighttime visible, enhancements in lightning mapping. I'm an oceanographer. I did a lot of my early work on, I'm going to date myself now, the Coastal Zone Color Scanner. Anybody remember the Coastal Zone Color Scanner, CZCS? Man, we've really come a long ways in terms of ocean color, both in terms of spatial resolution, but also spectral. And now we're able to do things with respect to looking at the health of coral reefs, with respect to looking at pollution, with respect to looking at and predicting harmful algal blooms. 10, 15 years ago, I could not have talked to you about having an operational harmful algal bloom product. We now do that in both freshwater and saltwater, largely due to some of these kinds of capabilities. And of course, when we start talking about IPCC requirements, nationally determined contributions, atmospheric composition is a capability we are particularly excited about. So let's talk about some of these products. Let's look at a sea surface temperature anomaly product here in the equatorial Pacific. I hope this audience realizes that this kind of image is one that you are going to really be seeing a lot of in the months to come. We are in a situation right now where there is a relatively high probability, above 60%, maybe even higher, of a significant El Nino in the next 6 to 12 months. So we're going to start seeing some very significant deviations from average temperature in some of these images. We also use this, as I said, for looking at coral reef ecosystems. One of the best indicators of potential for bleaching of a coral reef is the sea surface temperature. We can get ahead of the coral bleaching phenomenon by providing forecasts that are based on patterns and magnitude of sea surface warming that we're seeing here. A lot of this kind of information is also critical to fisheries. So when you start looking at these kinds of patterns and look at critical places, critical habitats like the North Pacific, where a lot of salmon reproduce, we can start making seasonal and even longer projections of relatively how many salmon we're going to see in the fishery off Alaska. And then some of these kinds of observations also contribute to our capability to do things like tsunami forecasting as well, giving us a better characterization of sea surface conditions, patterns, currents. But you get a sense of the diversity of products that we can develop using this kind of image. I want to show you another image that is specific to our wildfire tracking capability. And I bring this one up because before I took this job, I was living in the state of Oregon, which is in the top center of this slide. This particular image was taken in September of 2020, set of images, this video, and I happen to live, I'll try to time my talk here. You see those 3 fires in the middle of the state there? I lived about 5 miles from the one that is to the south. Fortunately, I had colleagues at NOAA. I was not with NOAA at that point. I owned some land that had highly flammable plants and trees and shrubs on it. Using this information, I actually made a decision that I needed to clear my property of that flammable material. It's a very personal application for me of some remote sensing imaging. And this is only going to become even more critical. We used to talk about fire season in the United States. We don't talk about fire season anymore. It's a year-round phenomenon. We're seeing these kinds of things happen in the dead of winter, and similar for many other phenomena. But you'll also see that this kind of information is going to be extremely useful for emergency responders, local firefighters. Our ability to track lightning as well as an indicator of where there's a higher probability that fires will start is enormously valuable. And then look at these images and realize that some of the trajectories, the smoke, and the dust that's emanating from these fires is also useful for the health community to make decisions about where we might see decreased air quality in a particular area. You can follow flow patterns there. A lot of this information was used, in fact, 3 years ago to warn people on the East Coast that they were going to start seeing some of the smoke impacts of these West Coast fires. These kind of fires and this kind of tracking also gives us an ability to understand where there will be burn scars. So once the fire is out, there's a problem with respect to how the terrain has changed. And then when you complicate that by extensive rains, don't forget, when you look at California, this is a state where just 2 years later, we started seeing these extraordinary atmospheric rivers. I guarantee you that the burned areas shown from this image were subject to extreme flooding. We call that cascading risks. So we went from having the extensive fires in 2020 to the heavy rains in subsequent years to increased flooding, where we might not have had it had there not been these burns. I talked a little bit about hurricanes. This is an image from Hurricane Ian a couple of years ago, where we now have resolution and cadence of imagery such that we can dramatically improve our forecasts of where the hurricane is going to hit and what the intensity of the hurricane will be. Now, this one is particularly important in the context of climate change, because if there is one thing we know, it is that the nature, the dynamics, the magnitude of these storms is changing. Many of you may have seen we are right now bracing for a severe typhoon to hit Guam. It will hit Guam later today. We know that from this kind of imagery. We know that many of the storms, Hurricane Harvey dropped more than 1.5 meters of rain. We didn't measure rain in meters when I was a kid. We're starting to see some extraordinary changes. What do we do with this information? It's not good enough to take an image like this one and hand it to a decision maker. It's cool, it looks great, they don't know what to do. So one of the really important things for us is to develop tools like this, and we work extensively with our colleagues at Esri to develop this, which we call the Climate Mapping for Resilience and Adaptation camera product. And basically, it takes all that cool data, information, intelligence, and translates it to decision aids, where people go to a portal, in this case, climate.gov, and can go to their area, anywhere in the United States, and determine what's my risk of flooding, of fire, or of any of these other issues. What exactly constitutes a climate-based or a climate-driven flooding event? What's my probability? Also, what are the sociological issues with respect to underserved communities in this area? Who's going to get hit hardest? And then start making decisions about what to do. So as you can see on the top, it gives you everything from the data, if you're into that, to some of the policy issues, to some of the tools that you can use to make decisions about preparing for these particular risks. Right now, what I've just shared with you is done not just by us. This is a snapshot of the constellation of our geostationary, near polar, and deep space. I haven't said much about space weather capabilities, but this next slide is really the kicker for this audience. This is where it happens. This is where the power of the remote sensing capability really bears fruit, and that is in the partnerships that we have. You can see just by how much we've populated the constellations and increased the coverage, the resolution, the diversity of measurements made. Obviously, we've got a little piece there that says commercial data purchase. This is a brave new world here, too. I've had any number of conversations just in the last 24 hours on that. And I would say one of the interesting things about this is how IAF is working with groups like the Group on Earth Observations, GEO. So I am the U.S. representative to GEO, and I'm particularly excited about the potential of how IAF, getting into this climate space, can work with GEO to talk about what do the products of the future look like. Products tied to global drought, products tied to heat health. So it's an exciting opportunity now for using the capabilities so well represented here at IAF to work with the international community. Last point is that I cannot drive home strongly enough with this audience that it's not good enough to just simply have the high quality, easily accessible data. At the end of the day, we have to be able to support decision making at all levels. And this slide calls out everything from emergency managers to policy makers to industry like insurance companies. And just to put a fine point on it, I show you on the slide on the lower right. 40 years ago in the United States, we would typically have $3 billion disasters every year. Right now, last year we had 18. The time between billion-dollar disasters, and that's inflation-adjusted, yes, in case you were wondering, the time between billion-dollar disasters has gone from roughly 3 to 4 months to more like 3 weeks. So we had better get in front of this problem, and you all are part of this solution. If I've done anything in these last 20 minutes, it's hopefully convinced to you, one, how we will use the information you are developing, and two, why it is so important to ensure we not only have a climate-ready nation, we have a climate-ready globe. Thank you very much.
Thank you so much, Dr. SPINRAD. I think you will agree with me. This was one of the most exciting presentations of this topic I've ever heard. Thank you very much, and we look forward to working together with you and with NOAA and with all your colleagues. Thanks very much for your engagement with IEF and for the exciting presentation.
Thank you very much.